Hey everybody, Matt here with LGN Tutoring. Today I'm bringing you guys another introductory dynamics problem. We'll start right off. The velocity of a particle traveling in a straight line is given by v equals 6t minus 3t squared meters per second, where t is in seconds. If s is equal to 0 when t is equal to 0, determine the particle's deceleration and position when t equals 3 seconds. How far has the particle traveled during the 3-second time interval, and what is its average speed? Alright, so again, one of the important bits of information we got is that right there. That's going to actually help us start this problem. So, here we go. We have that v is equal to 6t. v is equal to 6t minus 3t squared. Okay. Now we should know that acceleration is actually the derivative of velocity. And we have velocity right here. So we can actually, we want the deceleration, which is the same as acceleration, it's just in the opposite direction. So we can take the derivative of velocity to get that. Now the derivative of 6t is 6, and then to take this derivative, it's minus, lower the power, so 6t. Because 2 times 3 is 6, 6t. So that's the acceleration, and then it would technically be in meters per second squared. And we want to know the acceleration at t equal to 3 seconds. So when t is equal to 3 seconds, it is actually this, which is equal to negative 12, my bad. Negative 12 meters per second squared. So this is actually the acceleration, the deceleration, excuse me, when t equals 3 seconds. It is also asking for some other things, like where it is at that moment. So we can, this time we have to do a little bit something different. I'll go to a different page because we need some room for the math. Excuse me. Okay, so we're going to have to use the same velocity equation. So v is equal to 6t minus 3t squared, and we know that v is equal to ds dt. Now we can switch this around to get ds is equal to v dt, then we can integrate both sides. So the integral from 0 to s of ds is equal to the integral from 0 to t, and we want to know at 3 seconds, of 6t minus 3t squared dt. So this integral is pretty easy, it's just s. And then this integral is t, you have to increase the power to t squared, and then divide by 2, and it gets you 3t squared. And then you have to increase the power to the third, so it's t cubed, divide by 3, you end up getting 1 t cubed. And we want it from 0 to 3. So we basically just plug 3 in. 3 times 3 cubed minus squared, pardon me. 3 times 3 squared minus 3 cubed. And this actually ends up being 0. So, at 3 seconds, it ends at 0. So it starts at 0, it does some movement, and it comes back to 0. So now what we want to know is the distance the particle travels. This is displacement, so this is where the particle is relative to the beginning after it travels. Now, displacement's the kind of thing where, like, if you start here and end here, you could have done, like, this whole path, and it doesn't really matter because your displacement's still 0. But then distance is however much distance you actually covered, all added up. Now, this particle moved in a straight line, so it's not going to look like this. It's going to look a little different, but that was just my example for that. So now I'll grab another piece of paper, and we're going to continue in green because I don't have that many colors. And we're going to have to use the same velocity equation. So v is equal to 6t minus 3t squared. So we know that the particle starts somewhere. It starts somewhere, it moves, it stops, and then it comes back, and then stops again right there. We just want to know where that is. So in order to figure out how far it goes, we need to find out at which positions it stops. So we know that it doesn't move any at v equal to 0, when v is equal to 0. We know that v is equal to 0 here, and when it stops. So if we can actually just do some algebra and end up and factor out a t and get v is equal to t times 6 minus 3t. Now this is the same equation, it's just factored a little differently. That way we can find out where v is equal to 0. So v is equal to 0 at t is equal to 0 because of this, and it's also equal to 0 at t is equal to 2 because 3 times 2 is 6, 6 minus 6 is 0. So at these two times, t equals 0 and t equals 2, the velocity is 0, which is important. From that, we can actually go back to the equation we had for distance, or displacement rather, and find s. So s is equal to, that's a terrible s, I apologize, is equal to 3t squared minus t cubed. And what we want to do is we want to plug t equal 2 into that. So 3 times 2 squared minus 2 cubed. And when you solve that, you end up getting 12 minus 8, which is equal to 4 meters. Now, what this is telling us is it's telling us that the particle starts right here at t equals 0. It moves forward 4 meters at t equals 2. And then it comes back to 0 at t equal to 3. So basically, the distance it covered 4 meters forward and then an additional 4 meters backward for a total of 8 meters. So that's actually the distance covered. And I believe finally what the question was asking was, what is its average speed? Yeah. So now we can actually grab one final paper to get average speed. Here we go. Now average speed we're going to find a little bit differently. Speed is denoted in my class anyways as v sub sp, and then we want the average. So that is actually equal to the distance, which is st, so that's distance, whereas s is usually just displacement, over the time t. So what this comes out to be is it covers 8 meters over 3 seconds. So when you just divide this, you end up getting 2.67 meters per second. And that ends up being your final answer for the speed it covered, the average speed it covered during that travel. So there we go. That's the solution to that problem. We found out the deceleration, then we found out how the displacement at 3 seconds, we found out how much distance was covered in those 3 seconds, and we found out the average speed during those 3 seconds. So, there we go. That's the solution to that problem.